So this video is going to talk about how to find the direction angle of a vector. So one thing we know is that any vector has both a magnitude, right? So vectors have both magnitude and direction. So one of the things that talked about in another video is magnitude. So if you have a vector v, you can find the magnitude a couple different ways, but the magnitude could be the square root of the horizontal component squared plus the vertical component squared, and that's it. Now the question is, how do you find the angle at which the direction goes? And that's what I'm going to talk about here. So let's just jump right into it. Let's say that you have vector v, and that vector is in the first quadrant. Let's say it's 5, 7. So I'm actually going to graph this just so you can get a visual of it. So 5, 1, 2, 3, 4, 5, right? And then 1, 2, 3, 4, 5, 6, 7. And so this is the terminal point here. And there's your vector there. Okay, so what we're looking for, so that everybody knows, is I'm looking for this angle right here. So since that's the angle I'm looking for, one way to kind of see it come alive is to look at this as a right triangle. Kind of see that and use your understanding of right triangle trigonometry. So you know it went up 7 and you know it went right 5. You're looking for theta. If you're thinking to yourself, okay, what trig function could I use to find theta? Well, you know the opposite and you know the adjacent, so that means we should use tangent. So the tangent of theta equals 7 over 5. So what we're going to do is we're going to use the inverse tangent. Theta equals the inverse tangent of 7/5. And you're actually going to need a calculator. I'm going to be in degrees. So inverse tangent of 7 divided by 5, I get that to be 54.46, or so let's just say 54.5 degrees. So 54.5 degrees is what I get for theta. Now the tricky part about this is, well, I guess a positive is you'll always use tangent. So to find a direction angle, it's pretty straightforward. You're going to always use tangent, so that's nice to know. Can't spell. Struggling. It's all good. Always use tangent of theta, but if you don't want to graph it, you don't have to, because you know that in the coordinate plane, in past lessons in trig, you should know that tangent is equivalent to y over x. Well, every vector has a horizontal component and a vertical component, and so in this case 5 was my x and 7 was my y, and so as you can see it turned out to be tangent equals, or tangent of theta equals y over x. So that's the first thing. The second thing to remember though is that the inverse tangent, or the arctangent, only gives you angles in between these two. It only gives you angles between negative 90 degrees and 90 degrees, and it won't equal those because that's where they're undefined. So that's, the outputs are only somewhere between negative 90 and 90. So that raises the question, is what happens if you were to have say a vector in quadrant 2. So let's pick one in quadrant 2. Let's do this. Let's say that vector u equals negative 4 and 5. Okay, so if you want me to graph it, sometimes getting a visual helps. 1, 2, 3, 4, then 1, 2, 3, 4, 5. So negative 4, 5. There's your vector. So let me just show you what you're trying to find. You are trying to find this angle right here. Okay. So if you were to draw that triangle like I was saying before, the triangle goes straight down to the x-axis, and you're actually finding this much. And so this is 5 and this is -4, and it matters that you have that negative in there, so everyone would say tangent of theta equals 5 over -4. Inverse tangent to find theta, and that would be -5/4. Plug that into my calculator real quick. So inverse tangent, and I'm once again in degrees, -5 divided by 4, and I get -51 degrees, or let's go -51.34 degrees. Okay, so if your teacher says you can use negative angles, well then I guess you're good. But even then, if you think about it, -51 degrees is actually in quadrant 4, so you're still actually not good, because -51 degrees would be down here, right? That would be the vector, and that's quadrant 4, and you're not in quadrant 4. So what can we do? Well, remember, this much is -51 or 51. You don't really have to think about it as negative. So if halfway around is 180, we can actually just add 180 to -51.34, and you will have your angle. So plus 180, just use a calculator, makes life easier. And so then the real answer that we should be getting for theta, the one in orange, theta would equal 128.67 is what I got, or 66, excuse me, 128.66 degrees, and that's this right here, 128.66 degrees. And so that's the direction angle of the vector. We like to keep it positive, that angle measurement. So you have to be careful, especially if you have angle or vectors in quadrant 2, 3, or 4. You would actually have to do a little bit of addition or subtraction, depending on what kind of situation it is. But you'll have to do some addition, maybe add 180, maybe subtract from 360 in order to find that positive angle. So remember, you're always looking for that positive angle. And other than that, you should be all right. So that's how you find the direction of a vector. Use the tangent. All right. Have a great night.